Hello and welcome to Woven Chemistry. I'm Jean Weaver and I'm here to talk to you a little bit about decoding chemical formulae. This is the second video in a multi-part series, and what we're going to work on today is helping you get a much better understanding of chemical formulae, especially those for ionic compounds. And we're going to work our way to future videos where we're going to work on naming them and on drawing pictures of what these compounds look like at the microscopic level. So once again, these videos are not meant to teach you what chemical formula, what they mean. They're meant to take your existing knowledge and give you practice questions that help you develop a stronger foundational understanding. Okay, so hopefully you've got your stuff ready. Let's get going. So what we're going to do here is I'd like you to write the cation to anion ratio in the following formulae. But be careful, if the item doesn't contain both a cation and an anion, write Na. Okay, so if it's not an ionic compound, then there's not a ratio of cation to anion, and just skip those. Okay, it's really important to be able to notice which ones you skip and which ones you write the ratio for. Okay, so as always, pause the video, get out a sheet of scrap paper, and write your answers, and I'll share the answers with you in just a moment. All right, welcome back. Let's go through these answers. So this first one is an ionic compound, so the ratio is 3:1. The next one, we've got a metal and a nonmetal, so it's ionic. That is a 1:1 ratio. The next one with the nickel is a 1:2 ratio, 1:2. Okay, those parentheses help us distinguish the ratio subscript, the 2, from the 3 in the polyatomic ion. 36 is an Na that is not a molecular, that's not an ionic compound, it's molecular because both nitrogen and oxygen are nonmetals. All right, 37 is a tricky one. That is a 2:1 ratio. Okay, 2:1, and here's how you figure that one out. There are invisible, I call them invisible parentheses around that carbonate, and an invisible one. Okay, so polyatomic ions, you can always think of them as having invisible parentheses around them. Once we see those invisible parentheses, the ratio pops out and it's a 2:1. Okay, the next one is an Na because that's just an ion, it's not an ionic compound. 39 is also Na, as sulfur and oxygen are nonmetals, so that makes it a molecular compound. It's made of atoms, not ions. 40, now we see with those parentheses, this is easy. It's a 3:2 ratio. 41 is a little bit trickier. Hopefully you see those invisible parentheses. And this one is a 1:1. Okay, 1 sodium to 1 perchlorate, or 1 ClO4 minus 1. 42 is an Na. 42 is an Na because that is an ion. 43 is a 2:1. Okay, and 44 is a 2:3. Okay, so hopefully that's making a little bit more sense to you. Good variety of tricky ones and easier ones. Okay, let's go on to another set of questions. Similar thing, write the formula of the cation and its charge that in the following compounds. But remember, you only have cations in ionic compounds. So if it's not an ionic compound, write Na. All right? So again, pause the video, write your answers down, and then join me when you're done. All right, so this first one, the answer is Al and then a +3. How do we know it's +3? Well, because aluminum is always +3. You look at the periodic table, it's in that third tall column. That means it's a +3. CCl4 is a molecular compound, so this is an Na. Carbon and chlorine are both nonmetals. 47, sodium is the cation here, and sodium is always a +1. And we can see from 48, it doesn't matter what it's joined with, sodium is always a +1. This little 3 here doesn't dictate anything about the charge on the sodium. 49 is a little bit harder. Okay, because we got to do some thinking about this. The answer is a +1, but how do you figure that out? Because copper is a transition metal that has a variable charge. It could be +1 or it could be +2. Well, how do we know which it is? Well, this is where that ratio comes in. So let's think about that Cu and the OH. and we can tell that it's a 1-to-1 ratio of the cation to the anion. So let's think of the cation as being in red, a red cation, and the blue anion. Well, what else do we know? We know that the hydroxide is a -1. Okay, either you've got a chart of polyatomic ions or you just know them. I think it's better to just know them. And we know that this copper has a positive charge, but we don't know what it is. Well, remember, ionic compounds, all compounds, have to be neutral. So in order for this to be neutral, there's only one charge that copper can be. It has to be a +1. Okay, so note that we've taken into account the ratio, the 1-to-1 ratio, and once we look at that, it becomes very obvious that this is a +1. Okay, 50 is an Na. Okay, that's clearly not a cation, and it's not an ionic compound. 51 is a +2. Zinc is always +2. Okay, even though it's a transition metal where usually things have variable charges, zinc is always a +2. The nitrogen is a Na because it's an element. 53 is a little bit tricky. Don't get confused by the ClO. We're looking at the cation, which is lithium, and lithium is always +1 because it's in the first column of the periodic table. This one is Na because it's not a compound, it's just an ion. 55, silver is a +1. Silver is always a +1, similar to zinc. It's a transition metal, but it only has one particular charge. But let's say you forgot that and you're trying to figure it out. Well, we can figure it out from the information here. We can see that it's in a 2-to-1 ratio. So I'm going to do 2 red circles for the silver ions and 1 circle for the sulfur. And with the sulfur, we know that the sulfur has got to be a -2 because that's where it's located on the periodic table, tells us that. And so again, the compound needs to be neutral. We need a total of +2 charge shared over 2 ions. Well, that means that that charge on the silver must be a +1. Alrighty, and lastly for 56, this is not applicable because it's a molecular compound. All right, so moving on, we're going to do a similar task. This time we're going to write the formula of the anion and its charge in the following ionic compounds. Again, if it's not an ionic compound, just write Na. Okie doke. Pause the video and come on back when you've got your answers completed. Okay, welcome back. Let's see how you did. So 57, this is cyanide, and either you look it up or you know that cyanide is a -1. Now let's say you don't remember, you don't have a chart to look at. Well, we can do the same thing we did with the cations. Let's dissect the formula. We know that it's a 1-to-3 ratio, so that means that there's 1 red aluminum of a +3 to 3 blue cyanides. We don't know the charge on the cyanide, but we know they have to add up to +3. Well, now this makes it pretty obvious. The cyanide must be a -1. Okay, 58, sulfur's a -2. We get that from the periodic table. 59, this is a molecular compound, so you should write Na. 60, this one is O-2 because oxygen, if it's charged, is always -2. Okay, 61, hydroxide is always a -1. And 62 is Na because it's an ion. 63, sulfate is -2. Now, if you don't know what that is, let's see if we can figure it out. So we've got the ZnSO4, okay, and you should realize that this is a 1-to-1 ratio. Hopefully you remember that zinc is always +2. So then what could that sulfate be? Well, it's got to be a -2. Okay, 64, that's an element, so we don't have any anions, Na. 65, we've got 2 polyatomics here. Okay, hopefully you're recognizing this as an ionic compound. We've got the NH4 as the ammonium ion, and the OH as the hydroxide. So even though they're all nonmetals, you need to recognize the ammonium and the hydroxide. And our anion is OH-1. 63 is an element. Sorry, it's an ion, so that's an Na. 67 is a sulfur -2. and 68. I put this one in here just to give you a little extra challenge. Bromate is not usually a polyatomic ion that students are asked to memorize or that's in any charts. So let's see if we can figure it out. Okay, how do you go about figuring this out? Well, with these parentheses, it's pretty clear that the formula is BrO3. But the trick is, what's the charge? Well, let's think about it again. We see that they're in a 1-to-2 ratio, one red magnesium with +2, and we have 2 blue bromates. And looking at this diagram, it's pretty obvious it must be a -1. All right, so that takes us to the end of this series of questions. I really encourage you to come back for part 3. We're going to work on naming the compounds, and then that will take us very nicely to figuring out how to draw the microscopic pictures of them. Okay, so thanks for joining me, and I hope to see you again.